Hello children, let's see a very nice question from the chapter of Ionic equilibrium. Let's read the question. 0.35 liter of 0.1 molar NH3 and 0.15 liter of 0.1 magnesium chloride are mixed. What mass of ammonium sulfate should be added to the resulting solution, that is the above mixture, to just prevent the precipitation of magnesium hydroxide? Some data is also given. Ksp of magnesium hydroxide is given, Kb for NH3 is given, and molecular mass of ammonium sulfate is also given. So we basically need to find out how much amount of ammonium sulfate should be added to this mixture by mixing NH3 and magnesium chloride. There forms a precipitate of magnesium hydroxide. There forms a precipitate of magnesium hydroxide. So how can we stop this magnesium hydroxide being precipitated? So that is the question. By adding some amount of ammonium sulfate. And you know, Ksp is defined for what? Ksp is defined for saturated solution. Saturated solution means what? We are no more able to dissolve a particular solute in a given solution, or the maximum amount is dissolved in a given temperature. That point is called a saturated solution. So let's take the number of moles of magnesium chloride in this given solution by mixing NH3 and MgCl2. So we are basically mixing NH3 and MgCl2. So in that particular solution, what is the number of moles of magnesium chloride? You know very well, molarity is equal to what? Number of moles into volume, or number of moles is equal to molarity into volume. So if I apply that here, molarity into volume. So what is the molarity of magnesium chloride? 0.1. 0.1 into what is the volume of magnesium chloride? 0.15. So number of moles of magnesium chloride is 0.015. Or basically, if you see magnesium chloride, if I simply ionize it, it will give you 1 magnesium plus 2 and 2 Cl minus. So that means 1 magnesium chloride is getting 1 magnesium plus 2. That means, therefore what I can write? Number of moles of magnesium plus 2 is also how much? 0.015 itself. Now, on mixing NH3 and magnesium chloride, what will be the concentration of magnesium plus 2 in the solution? That will be number of moles of magnesium plus 2 divided by new volume of solution. That is number of moles of magnesium, how much we got? 0.015 divided by what is the total volume by mixing, that is from NH3 0.35 plus from magnesium chloride 0.15, that is 0.015 divided by 0.50. So that is, if I can simplify this, that is 15 into 10 to the power minus 3 divided by 5 into 10 to the power minus 1. So if I cancel this by 3, and this will become 3 into 10 raised to minus 2, or the concentration of magnesium plus 2 is equal to 0.03 molar. Is that clear? Now in that particular solution, the concentration of magnesium plus 2 is 0.03 molar. Now let us think that the given solution is saturated, so that how much amount of OH minus is needed to make magnesium hydroxide saturated, because Now in the solution we have magnesium ion 0.03 molar. So how much OH minus is needed so that the concentration of magnesium hydroxide in the solution becomes saturated? So how can we do that? It is very simple. So let's see, magnesium plus 2, magnesium hydroxide splits into what? It will split into magnesium plus 2 plus 2 OH minus, or simply KSP is equal to concentration of magnesium plus 2 into concentration of OH minus the whole square. Or at the saturated condition I can write the concentration of OH minus square will be equal to KSP by concentration of magnesium plus 2, or what I can write, concentration of OH minus is equal to square root of KSP divided by concentration of magnesium plus 2. Now if you see in the question, the KSP value is given how much? 1.2 into 10 to the power minus 11, that is 1.2 into 10 to the power minus 11 divided by, what is the magnesium concentration we find out? 0.03, or I will write this 3 into 10 to the power minus 2 the square root. Or this, what we can write, we can simply make it like 0.4, this will become 0.4 into 10 to the power minus 9, right? So this will get cancelled, or what I can, this will be 4 into 10 to the power minus 10 whole root, or which is equal to 2 into 10 to the power minus 5 molar. That means in that given mixture, when the concentration of OH minus becomes equal to 2 into 10 to the power minus 5 molar, magnesium hydroxide becomes saturated solution. Means it is not going to precipitate, it becomes the saturated. Now let's see, we have made the saturated solution. Now we need to identify how much ammonium sulfate I need to add, so that we need to maintain this concentration of magnesium plus 2 as 0.03 and the concentration of OH minus as 2 into 10 to the power minus 5. So how can we do that? It's very simple. Now in the solution we have NH3 is there. In the solution we have NH3 is there. So this NH3 is going to mix with water. It is in the aqueous solution, so it will change into what? Ammonium hydroxide, which will exist as NH4 plus and OH minus. Basically, NH3 has accepted H plus from the water, so it is basically the Kb, base dissociation constant Kb. If we write the equation, it will become concentration of NH4 plus into concentration of OH minus divided by concentration of NH3, or even solve here, we can solve the concentration of NH4 plus is equal to, we can solve very easy, Kb into concentration of NH3 divided by concentration of OH minus. Now in the question, the Kb value is given how much? The Kb value is given 2 into 10 to the power minus 5, that is, which is equal to 2 into 10 to the power minus 5. And what could be the concentration of NH3 in the solution? So the same way how we find out for magnesium, we can also find out for NH3. So that you see number of moles of NH3 is how much? 0.35 into, because volume into molarity. So if I do that, number of moles of NH3 divided by volume of solution, number of moles of NH3 is how much? 0.35 liter, volume into molarity 0.31 divided by the volume of the solution was how much? 0.35 plus 0.15, that is 0.50, that is 0.035 divided by 0.5, which is equal to what I can write as 0.07 is the concentration of NH3 in the given solution. Any doubt? So I substitute that value in our previous equation, that is 0.07 divided by, and the concentration of NH3 also we just got how much? OH minus we got how much? 2 into 10 to the power minus 5. 2 into 10 to the power minus 5. So these two I can cancel. So what I will get the value as 0.07 molar. So the concentration of NH4 plus is how much? 0.07 molar. Any doubt is there? Now if I write the formula of ammonium sulfate, NH4 twice SO4. So in one molecule of ammonium sulfate, how many NH4 is there? 2. Right, 2 NH4 is there. So if we get the concentration of NH4 plus the 0.07, what will be the concentration of NH4 twice SO4? It will be definitely, if you take 1 NH4 twice SO4, there are 2 NH4. That means half of NH4 is the concentration of this ammonium sulfate, that is 0.07 divided by 2, that is how much? 0.035 molar. Any doubt is there? Any doubt is there? No. So you got the molarity. You got the molarity. So this means what? This means 0.035 molar. What is the meaning of that? It means 0.035 moles of ammonium sulfate in 1 liter. This is the meaning of 0.035 moles of ammonium sulfate in 1 liter. Therefore, what I can write? The mass of ammonium sulfate. Mass of ammonium sulfate. How can we find out? It will be number of moles into molecular mass of ammonium sulfate ആയിരിക്കും. So number of moles is how much? 0.035, and the molecular mass is given in the question as how much? 132. So once you multiply this, you will get it as 4.62 grams. So that is present in how much liter? 1 liter. And if you remember, our question is just 0.5 liter upon mixing NH3 and MgCl2. You will understand the given volume is just half liter. So therefore, in half liter, 0.5 liter, what will be the mass of NH4 twice? That will be 2.31 grams of ammonium sulfate is needed. So what is the answer for this question? 2.31 grams. So I just conclude whatever we discussed. The question asked here, what is the amount of ammonium sulfate we need to add so that we can prevent the precipitation of magnesium hydroxide? For that purpose, we identified what is the available concentration of magnesium hydroxide, magnesium plus 2 in the solution. So using that, we just identified what is the amount of OH minus needed so that I can keep a saturated solution of magnesium hydroxide. That means when OH minus concentration is 2 into 10 to the power minus 5, and this magnesium concentration, magnesium plus 2 concentration is 0.03, this magnesium hydroxide remains saturated. It is not going to get precipitated. That is KIP is equal to KSP situation. So it is not getting precipitated. Able to understand? So we are fixing the concentration of OH minus as 2 into 10 to the power minus 5. Using that data, we have identified what could be the possible allowed concentration of NH4 plus in the solution, and we found out that is 0.07. So if NH4 plus concentration is 0.07, then the concentration of allowed concentration of ammonium sulfate will be half of that is 0.035. So using that, molarity is moles per liter. We just wrote 0.035 molar means 0.035 moles of ammonium sulfate in 1 liter. So from that we just find out what is the mass of ammonium sulfate in the liter per liter of solution. Then we just find it for half liter and we got the answer as 2.31. So I hope this discussion finds or helps you very well. and let's see in another discussion with another very good question. So I wish all the best for you. We see soon. Take care. Bye bye.